Hello everyone, my name is Komasinyolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, so for this video, we will be looking at the straight line. This is the simplest type of function that we are going to look at. It only gets more complicated from here, although it doesn't get any more difficult. Okay, so a straight line is as follows. If you've got a Cartesian plane like that, and this is your x-axis and this is your y-axis, a straight line would look like this. It would either go that way, would go that way, it could go any direction, could even go completely vertically, it could be completely horizontal, so it could go towards any direction, it could slope towards any direction. Okay, so this is what a straight line looks like. It's a straight line graph, and to explain it further, let's say okay, I'm gonna draw your Cartesian plane again. You've got your Cartesian plane, you've got your x-axis, you've got your y-axis. Okay, and then I'm just gonna draw one straight line right now. Okay, so let's say I draw a straight line that looks like that. Okay, and then it continues forever. That's what those arrows mean. Right, now a straight line graph, right? A straight line graph is or a straight line function is a type of function where you only have one x value corresponding to one y value, and they relate to one another. So all the x values and the y values of the graph relate to one another in such a way that if you join all the points, right, if you join all the points where those x values and y values relate, then you would get a straight line. Okay, so that's simply what a straight line graph means, or straight line function, or a linear function means. It means that for a linear function, every x value corresponds to a specific y value, such that if you join the dots, if you were to plot this line, if you were to plot the dots on a Cartesian plane and you were to join the dots, then the dots would form a perfect straight line, right? And a straight line has an equation, or it has a relationship that we can use to describe this tendency of these straight lines to line up in a perfectly straight line. Okay, so what is that relation? What is that description of a straight line? Well, we've got a standard form for that description, or for that relation. Okay, so the standard form for a straight line is y is equal to mx plus c. This is the standard form of a straight line. Okay, this is the relation between your x values and y values. Remember what an equation is. An equation is simply a description of how your x values relate to your y values, or how they relate, how they correspond to one another. Okay, so now I'm going to describe the different terms of this equation. I'm just going to rewrite it down here. You've got y is equal to mx plus c. Now, what do all these terms in this equation mean, right? In this relation, in this standard form, what do all these terms mean? Well, m is your gradient, okay? This is what we call the gradient. This should actually be revision if you're in grade 12. M is your gradient. C is your y-intercept. C is your y-intercept. I will explain what these mean graphically in a couple of seconds or minutes. This is your output. Okay, this is your output. This is the value of y you get when you put in a certain input. So your x value, your x is your input, your y is your output, your m is your gradient, your c is your y-intercept. If you don't want to say your m is your gradient or your slope, right? It's your gradient or your slope. They mean the same thing, gradient or your slope. Okay, so now let me illustrate what those mean in the form of a graph. Okay, graphically, let me illustrate what those mean. Okay, so you've got your Cartesian plane, Let's say you've got a straight line. You've got a straight line that does that. Okay, goes on forever. Okay, and then you know that the standard form of this straight line is y is equal to mx plus c. Okay, now let's start off with the y-intercept because it's quite simple. The y-intercept, remember the y-intercept is c. It's that value there. That's your y-intercept, that value there. Okay, that's your y-intercept. And your y-intercept is simply the value on your y-axis that the graph goes through, right? In other words, it is the point on your y-axis. It is the point on your y-axis. Your y-axis, this is your y-axis, right? This is your y-axis, this is your x-axis. Your y-intercept is the point on your y-axis where your graph cuts through. So at that point there, that is what c is. So whatever number you have in place of c, whatever number you have here, that's going to be the number there. That's going to be the number there. That is your y-intercept. It is the point on your y-axis at which your straight line cuts, or it goes through, or it intersects. Okay, so that is your y-intercept. Okay, so let's say for instance you have an equation. Before I describe the gradient, let's say you've got y is equal to 2x plus 3. Okay, now if you look at this equation here, and you try to relate it to the standard form, y is y, right? Y is y. So these two y's are the same thing, right? These two y's are the same thing. M is 2, right? Why am I saying m is 2? Because m is the value that is next to the x. I've got my x there and I've got my x there. So if I have my x there and I have my x there, then the value next to the x has got to be my m. So that's my m there. My m in this case is 2. Right? So what is my c? My c is the value that stands on its own there. So in this case, c is 3. Right? C is 3. Meaning that if I were to plot this graph, right, this graph would cut the y-axis at 3. It would cut so that value there would be equal to 3. Okay, so that's simply what the y-intercept means, and that is what c is. Okay, so c in the standard form is your y-intercept. Okay, cool. Now let us describe what m is. M is your gradient, m is your slope. I draw in my Cartesian plane, there, and I draw in a straight line. Say it looks like that, and I have my standard form of my equation, which is y equals mx plus c. M is the gradient. Remember, m is the gradient. Okay, so m is the gradient of my line. Gradient, or you can call it a slope if you want. Okay, you can call it a slope. Now, that point there is c. That's your y-intercept. Okay, that's your y-intercept. Now, what is my gradient? Well, my gradient is tells me how much my graph slopes. Okay, it tells me how much my graph slopes. So a graph, if you look at me in the picture there on the bottom left corner, if your graph is like that, it has a low gradient. So the more your graph slopes, the steeper your graph becomes, the higher the gradient. Okay, so now your gradient on this graph is that there. So that's the slope there. That's the slope there. Okay. That's the slope there. So I think a simple way for me to explain this would be so how do you know if you have a big slope or a small slope? Okay, so the longer that side is, right? The longer that side is, or the higher that side is, the bigger your slope. Okay, so the bigger your slope. think that's an easy way to remember it. The higher that side is, the bigger your slope. Okay, and the shorter it is, the smaller your slope. Okay, so the slope for this graph is the same. The slope for this graph is the same. The higher that side is, and just by the way, the higher this side is when you compare it to this side. Okay, let me make that make a bit more sense before I move on. I'm just going to draw another Cartesian plane in there. So I'm going to draw a lot of these Cartesian planes to explain these things. So let's say you've got two graphs, right? One graph looks like that, and the other graph, let's say it looks like that. It doesn't matter that they intersect there, just ignore that for now. Okay, so those are your graphs there. Now, between these two graphs, which has a bigger slope and which has a smaller slope? Well, just draw in a triangle, right? A triangle, and 2 points of the triangle must cut through the graph, or they must stop at the graph. So my triangle, I'm going to start it here, and I'm going to go down, and then I'm going to come up here, right? Then I'm going to do the same thing here, and then I'm going to come here. Okay, now there. Okay, there and there. Now, if you look at these two graphs, which one has a bigger slope or bigger gradient and which one has a smaller gradient? Well, you look at this side and you compare it to that side, right? Here, you look at this side and you compare it to that side. Now, this side in this case compared to that side is it's closer to the side than this graph at the bottom there. This side is much smaller than that length there. This height is much smaller than that length. Since this height is smaller than that length, or compared to this one, compared to this graph here, since this side for this graph, since the side for this graph is smaller than that, then this graph has a smaller gradient, or it has a smaller slope, okay, than that graph there. Okay, so that's how you compare slopes. So the more steep or the more sloped your graph is, the higher the vertical side is going to be, and the bigger your gradient is going to be. Okay, now that's how you can visually tell which graph has a bigger slope, or which. So the steeper graph has the bigger slope, and the shallower graph, by shallow I mean more horizontal. The closer it is to horizontal, the smaller your gradient is, or the smaller your slope is. Okay, now that is what your gradient is, and that is the value of m that we were talking about up here. It's that value of m that we were talking about up here, and it's the value of m that we were talking about here. Okay, that's what m is. Now, how do you calculate m? How do you calculate the value of your gradient? Well, it turns out that there is an equation actually where we can actually get numbers and magnitudes to actually see what the actual value of your slope is. Okay, now there's an equation for your slope. Your slope given by m is equal to y1 minus y2 divided by x1 minus x2. Okay, so I'll explain what those mean, and if you want to write this in compressed form, it just means the change in your values of y. So a triangle simply means change, so delta y over delta, let me just write that nicely, delta x. Okay, so remember these two equations. You should have them in your formula sheet, but they should be easy to remember. Now, what does this equation mean? This equation means that, let me draw a line here, a Cartesian plane here at the bottom. You've got a Cartesian plane, got a Cartesian plane, you've got a Cartesian plane, you've got a Cartesian plane, then you've got a straight line, right? You've got a straight line, and on this straight line, say you decide to look at 2 points. Just 2 points. This line has more than 2 points. It has a lot of points. Remember, a straight line is simply a lot of points joined together to form a straight line. right? But let's say you decide to look at just only 2 points, right? You decide to look at only 2 points. Say you decide to look at this point and any other point on the graph, that point there, right? Doesn't matter where the points are. It could be a point here. Just it has to be 2 points. Let's use these 2 points, right? Now, a gradient, let's say they asked you to calculate a gradient of this line. Let's say you choose 2 points, 2 random points, and you call this point point 1, and you call this point point 2, right? You just give them a name, point 1 and point 2, right? And you join those 2 points such that they form a triangle, right? So if you join those 2 points, you've got, you use straight lines, you've got a point there, and one of the straight lines has to be parallel to your x-axis, the other straight line has to be parallel to your y-axis. You draw a right-angled triangle. It has to be a right-angled triangle, right? Meaning that that angle there has to be 90 degrees. This is your triangle that you draw in, right? Now, what you want to calculate is the slope of this line here. You want to calculate the slope of that line there, or the gradient of that line there. How do you do that? Well, you will know that each point on the straight line is represented by coordinates, right? It's represented by coordinates. So point number 1 there is represented by coordinates x and y, right? X and y. And this point is also represented by coordinates x and y, right? X and y, right? Okay, but these points are not the same. This point is not the same as that point because they are at different locations. So they're not the same points, right? They're not the same points. Since they are not the same points, we want to give them names. We want to identify what they're called so that we can tell which point we're exactly talking about. Now, since I called that point there, I called it 1. I'm going to say, okay, for 1, my x value, it's x at point 1 and y at point 1, right? X at point 1 and y at point 1. So I call it x1 and y1. For point 2 there, my x, I'm going to call it x at point 2, x at point 2 and y at point 2. Okay, x at point 2 and y at point 2. So now I've got x1 and y1. I've got x2 and y2. Now, in order for me to calculate the slope, I just have to say x1, the x value at coordinate number 1, minus the x value at coordinate number 2. Get that value? Get the value of y1, which is the y value at coordinate number 1, and the y value at coordinate number 2. Get those values, and then divide those two values by each other, putting the y as the numerator, the y on top, the change in y over the change in x, right? So, remember, our equation for our gradient is m is equal to y1 minus y2 divided by x1 minus x2. Okay, so y1 is that value there. Then y2 is that value there. X1 is that value there, and x2 is that value there. Once you have all 4 of those values, then you can calculate the gradient or the slope of your graph. Okay, so let's do an example. Let's do a quick example. Like I said, if you're in metric, this should be very basic. It should be revision. But if you're just starting out with these things and you need this much detail, then this is the video for you, right? So you've got that and you've got that. This is x, this is y. Okay, this is x and this is y, and you've got, let's say, I'm just going to give you a graph that looks like that in this case, right? And let's say I say to you that point there, the coordinates at that point there are -2 and 3, right? And I say the coordinates at that point there are, let's say, 4 and minus, let's say -2. Okay, 4 and -2. Right. Now ask you to calculate the gradient. Right, I ask you to calculate the gradient. I ask you what is the gradient of this thing here. Well, you have to choose which coordinates are my point 1, which coordinates are my point 2, and then substitute and solve, right? I'm going to choose this. It doesn't matter which one you choose to be 1. You could choose the one on top to be 1, and then choose this one to be 2, or you could choose this one to be 2, and this one to be 1. Doesn't really matter, right? Okay, and you know that the equation of your gradient m is equal to y1 minus y2. I always struggle to write my 2's. 2 all over x1 minus x2, right? And then you just substitute. Okay, you substitute. What is y1? What is y1? Well, here's my coordinate 1. Here's my y1 here. My y1 is 3, right? My y1 is 3. So this is going to be 3 minus, because I have a minus there, y2. What is y2? Well, I chose to call this 2. So my y2 is that there. Now my y2 is negative 2. So you keep this minus here, but you also keep the minus for y2. So this is going to be minus 2, right? Divided by, what is x1? x1 is that value there, because this is coordinate number 1. This is coordinate number 1. This is my x value. So my x1 is minus 2 minus, because I have a minus there, then minus x2. x2 is 4, right? Because I chose this to be coordinate number 2, so x2 is 4. And then if you solve this, you're going to see that you get 5 on top divided by minus 6. Okay, and then this is your slope. This is your gradient for this is your question basically answered. Okay, let's do another quick example. Let's do another quick example. Let's say you've got your Cartesian plane like that. Let me just zoom in quite a bit. You've got your Cartesian plane, Cartesian plane. Then you draw a straight line. Then a straight line looks like that. And then you've got a point here and another point there, right? And they tell you the coordinates for this are 1 and 3. They tell you the coordinates for this are 4 and 5. Okay. They ask you to calculate the gradient or the slope of this line. Well, your gradient is going to be m is equal to, let me just write it a bit higher, m is equal to y1 minus y2 divided by x1 minus x2. So m is equal to, you choose. Now let's say I choose this point to be my point 1. Point 1, I choose this point to be my point 2, right? Okay, if I draw a triangle, it's going to look like that, but I'm not going to draw it. You don't have to draw in the triangle. I was just drawing it because I was explaining. I wanted to show you that we're looking at the sloped side of the triangle. Okay, now y1, what is y1? Okay, let me do this. What is y1? Well, y1 is the y value at point number 1. Point number 1 is here. The y value is 3. Okay, so that's going to be 3. Then minus, what is y2? y2 is the y value at point number 2, right? So that's 5 divided by, what is x1? x1 is the x value at point number 1. So that's 1, right? 1 minus, what is x2? x2 is the x value at point number 2, and that's 4. Okay, and then this is going to give you minus 2 divided by minus 3. And that's going to be your slope, 2 over 3, because the negatives will cancel. So m is equal to 2 over 3 for this graph. Okay, so this is how you would solve this. This is very basic. Now let's combine the two. Let's combine the gradient and the y-intercept and talk about them both at the same time, right? Now, if you have got, if you've got Cartesian plane, and you've got, say, an equation, y is equal to minus 2. I don't know why I like 2 so much when I struggle to write them. Minus 2x plus 1. Right, minus 2x plus 1, and they ask you what is the gradient of this equation. Well, you will be able to tell me immediately that the gradient of this equation m, the gradient of this graph m, is equal to minus 2. Why? Because minus 2 is the value that's with the x, and so m is equal to minus 2, right? And if they ask you what c is, then you know that c is the y-intercept, so c is that value there, so c is equal to plus 1, or you could just say 1, you don't have to write it. And if you were to show these, if you were to sketch this quickly, you would tell me that, okay, since c is equal to 1, and I know that c is the point of the graph at which it's the point on the Cartesian plane at which the graph cuts through the y-axis, you would tell me that 1 is somewhere there. There's your 1 there, right? And then your gradient in this case is negative. Now, I forgot to mention, if your gradient is negative, right, if m is less than 0, then your graph looks like that. If m is greater than 0, then your graph does that. Okay, it follows that direction. It slopes upwards to the right. And if it's less than 0, it slopes upwards to the left. You should remember this. Okay, now for this graph, you can see that m is minus 2, meaning your graph will be moving that way. It'll be sloping upwards in that direction. So your graph will look like that. Okay, so let's do another example so that I can hammer that point home about the slope. If you've got I'm going to draw in your Cartesian plane, and I'm going to write a random equation. Y is equal to 4x minus 2. Now I ask you to quickly sketch this graph. Well, you will tell me that the y-intercept minus 2 is down there, somewhere there, and m is equal to 4. So m is equal to 4, meaning that m is greater than 0. So your graph is going to go like that, right? So it's going to cut through minus 2, and it's going to go up like that. Okay. So so you can basically draw your graph illustratively, not in detail, not with all the numbers or the values, but just illustratively. You can draw your graph from the gradient and the y-intercept. You can draw a straight line graph. Okay. Now there's also what we call your x-intercepts and your y-intercepts for your graph. Okay, so what is an x-intercept and what is a y-intercept? Let me just do this. What are your x-intercepts and what are your y-intercepts? X-intercepts x-intercepts, y-intercepts. Okay, I'm going to start with your x-intercept. Your x-intercept are, okay, so for your straight line graph, the x-intercept is the value of x where y is equal to 0. Okay, so in other words, it's the point on your Cartesian plane, on your x-axis that the graph cuts through. Okay, it's the point on your x-axis that your graph cuts through. If I were to show you that on a Cartesian plane, all these things are easy to understand when I show them on a Cartesian plane. So you've got a Cartesian plane like that, and you've got your straight line going through like that. So the point on your x-axis where your graph cuts through, that is your x-intercept. Okay, and at that point, your value of y is 0. Your value of y is 0. And you will notice in my definition up here, this is why I say the value of x where y is equal to 0. Okay, now, if you have if you have an equation, y is equal to 2x plus 3, right? And I ask you, what is the x-intercept? What is the x-intercept? Well, you would tell me that I know that the x-intercept is the value of x where y is equal to 0. So all you have to do is take that equation, and wherever you see a y, put in a 0. So y is equal to 0. So instead of putting in a y there, you're going to say 0 is equal to 2x plus 3, and then you're going to solve, right? You're going to solve. So when you solve this equation, I'm not going to go into detail with solving. The 3 goes to the other side, and then you've got 2x. So therefore, your x is equal to minus 3 over 2. So that's your x-intercept. Meaning that if you were to sketch this graph on a Cartesian plane, 2x plus 3, if you were to sketch this on a Cartesian plane, this is y is equal to 2x plus 3, and you have this graph here that does that, okay, or that does that. We know that we just found right now that our x is minus 3 over 2, so it's minus 3 over 2, which is minus 1.5. That value there is minus 3 over 2, right? Because this is your x-intercept. X-intercept for this equation. Why? Because that's the point on your x-axis where your graph cuts through when y is equal to 0, right? When y is equal to 0, they're at the origin. That's your x-intercept. Okay, that's all that it is. And your y-intercept is what is your y-intercept? Before I actually draw things, y-intercept. Y-intercept. Your y-intercept is your value of y. This is an f here. Your value of y where x is equal to 0. What does this mean? This means that if you've got a Cartesian plane like that, right? If you've got a Cartesian plane like that, just scroll up a bit, and you draw a line, a straight line that does something like that, then at that point there, we discussed it earlier on, this is your y-intercept, this is the value for C, right? And at the same time, this is your y-intercept for a straight line, right? It's your y-intercept, meaning that the value of x, these are the different values of x. These are the different values of x, but at that point, your value of x is there, and at that point, x is equal to 0. And this is why up here I said your y-intercept is your value of y where x is equal to 0. Okay, so you go on and you solve. So let's say, for example, you've got an equation y is equal to 7x minus 3. Okay, 7x minus 3. Well, you will be able to tell me immediately what this graph generally looks like, right? You see that the m, the gradient there is 7, so m is greater than 0, meaning your graph has that shape, right? It has that shape. And you can see that here, this is C. C is minus 3, right? So minus 1, minus 2, minus 3. It's there. So you can tell me, you will be able to tell me that your graph, it cuts through C, and it goes up there. It goes up like that. Okay, so let me just try to draw it nicely. It cuts through, it cuts through there. Jeez, I'm missing the point. It cuts through there, at that point there. That's your minus 3 there. It cuts through that point, right? This is what your graph looks like. But, to calculate this value, you can obviously see it by inspection that it's minus 3 there. But for you to get to that value, you would have had to calculate it. You can also calculate it. So equation is 7x minus 3. Let's calculate it. Y is equal to 7x minus 3. We know our y-intercept. What if they ask you to find your y-intercept and to show your calculation? What if they ask you to show your calculations? Well, you say x is equal to 0. For our y-intercept, x must be equal to 0. That's from the definition, right? That's from this definition here. Y-intercept is the value of y where x is equal to 0. Now, how much do we get when x is equal to 0? Well, if you look at the equation, instead of writing x, wherever you have x, you're going to put in 0. So there, you're going to replace that with 0. So you're going to say y is equal to 7. Instead of writing x, you're going to say times 0 minus 3. And we know that anything multiplied by 0 is 0, so that will fall away. That will fall away, and then you will ultimately be left with y is equal to minus 3, and that is your y-intercept, minus 3, and you can see that it's the same as that value there. That's your c, and it's the same as this value here. That's your c, this value here, which is c, okay, which we spoke about earlier on in the very beginning of this video. Okay, so I think this video, I dedicated actually a lot of time in explaining what each of those terms are and giving you examples. This is content that should have been covered earlier on in the earlier grades before grade 12. So it should be revision. So in terms of examples, carrying out examples where we're combining all these concepts, the gradient, the y-intercept, x-intercept, and sketching of the linear graph, I'm not going to do that. That's it should be, or maybe it should be in a separate video. If we do decide to do it, we'll do it in a separate video. But I think just covering the concepts here, the basics, as far as I did, to as much detail as I did, should be enough for, it should have been revision enough. And any further assistance can be sought out elsewhere. Okay, so this is where I'm going to stop with this video. Till next time.